Hello and thanks for having me here to present this GCC OpenAcc update work of the past year. I'm Thomas Schwinge, working at Siemens nowadays, which has acquired Mentor Graphics, which has acquired Code Sorcery. We are still the same group of people working on these toolchain things. This presentation is pre-recorded as there is a chance that I may not be around for a live presentation. GCC, the free software, open source software GNU compiler collection, has one major release every year. GCC 11 was released this year in April. This again includes work by our group as well as work by other companies, quite a number of, and some individual contributors. Our work continues to be funded primarily by service contracts. Talk to us for any needs you have for GNU tools support. So GCC 11, current stable release, supports OpenAcc 2.6 features with code offloading to AMD and NVIDIA GPUs using the GCN and NVPTX instruction sets. Then there is an OG11 development branch that we set up. That's a public branch based on the GCC 11 release branch plus new features. These are the work that we inherited from the previous development branch, the OG10 branch, plus a new ongoing development that gets installed in this branch. This provides early access to GCC 12 features, which is the next major release due in spring next year, which is the general GCC development branch where all ongoing development gets onto. So our changes either go directly into the GCC 12 branch or first in the OG11 branch as a staging branch in a way. So the last year our focus for OpenAcc work has been on OpenAcc kernels work, which is the well, I say here compiler magic, doing several things. For example, array access delinearization, so turn one-dimensional memory accesses back into multi-dimensional array accesses, with which together with scalar data privatization helps that compiler passes can figure out data dependencies related to loop iterations, and that's the core work of the OpenAcc kernels pass in the compiler, is to turn loop constructs, OpenAcc loop constructs with an auto clause, into either a sequential clause if something cannot be run in parallel, or an independent clause if something may be run in parallel. That's the very, very high level summary. Actually, we have a talk upcoming at the Linux Plumbers conference on the GNU tools track, called OpenAcc kernels improvements by my colleague Frederick Harvard. So you may register and attend that if you're interested in more details, or talk to us, of course. That OpenAcc kernels work has been done on a separate development branch, which is currently being integrated into the general OG11 development branch, and then will be available to the public. Further, last year we have done upstreaming, and that includes revision of existing OG10 development branch work to integrate that into the GCC mainline branch so that it will be available to all users of GCC. This included preparational work for the OpenAcc kernels, which is to decompose OpenAcc kernels constructs into several parts, into a sequence of individual compute constructs. This is mandated by the described semantics of OpenAcc kernels regions as per the OpenAcc specification. We have added support for OpenAcc worker parallelism for AMD GPUs. So for NVIDIA GPUs, this has been working for a long time, but for AMD GPUs, this has been done differently as a GCC middle end transformation for the state changes. That's a different approach from the NVPTX backend, where it all happens in the backend itself, and remains to be seen how we can integrate these two approaches, which makes more sense. There is support now for interactive debugging for GCN offloading kernels, so using the standard GDB, or I think you still need to use ROC GDB, which is a slightly modified variant of GDB. And then you can actually, for example, step through your offloading kernels and view registers or variable contents, things like that. And also again at LPC, at the GNU Tools track, we have a demo coming up by my colleague Andrew Stubbs on this very topic. I have myself not yet seen that, but I will be sure to attend that. Sounds like a very interesting feature. For NVIDIA GPUs, something similar ought to be possible by using CUDA GDB, but as far as I'm aware, this has not yet been attempted to make work with GCC code generated. Related to this debugging thing, also at LPC, we have, not we, but AMD, two people from AMD have a presentation upcoming about dwarf extensions for optimized SIMT SIMD GPU debugging. Dwarf is the underlying open standard for describing debug information in executables of the GNU toolchain originally, I think, and similarly also used by LLVM, for example. Okay, further we have integrated into mainline quite a number again of bug fixes, for example related to OpenAcc specification adherence, things like data privatization or sharing, depending from which viewpoint, at the OpenAcc gang level of parallelism, so that such variables use GCN LDS memory or NVPTX shared memory, so that the gangs have privatized memory, but inside one gang all workers and all OpenAcc vectors see the same memory values. Again, a number of OpenAcc Fortran bug fixes and enhancements, like related to array sections, strides, and derived types versus arrays. High-level summary. Some changes related to correctness of OpenAcc async implementation, and yeah, always keeping up with breaking changes of LLVM HSA for GCN or PTX and CUDA for NVPTX. So we use the LLVM assembler for GCN, which is the LLVM dependency here. HSA provides the library for accessing the AMD GPUs, and yeah, the GCC NVPTX backend generates PTX code, so we have to adhere to the PTX specification for that code is being loaded using the CUDA driver library, where we also have to maintain compatibility, which is not bad generally, so there are not a lot of breaking changes, but every once in a while things get deprecated or changed for whatever reason. We've done optimizations again in the GCC middle end general optimization passes, as well as the GCC backends for GCN and NVPTX. We've added diagnostic uppercase W OpenACC parallelism to diagnose potentially suboptimal choices of OpenACC parallelism. So when, for example, your OpenACC parallel construct specifies num workers to request a number of workers for using OpenACC worker parallelism, but you don't actually have an OpenACC loop construct with a worker clause inside. Things like that. Okay, then the next steps, or what is going on currently, is taking further existing changes from the OG11 branch and make these fit for integration into GCC mainline. So yeah, a lot of the changes that are on there require some minor or major revision. Working on that ongoing. Those changes should still make it into GCC 12 until the cutoff date, which is in winter usually. After that we can no longer get them into GCC 12, but they will have to wait until GCC 13 next year probably. This integration also applies to the current OpenACC kernels work, so we are hoping to get that into GCC 12. We have been contracted to work on OpenACC 2.7 features, but that work has not yet been scheduled, so I cannot confirm yet if that will make it into GCC 12. And of course other items as prioritized by our customers. And we also, of course, plan to continue working with the OpenACC Technical Committee to refine the specification and contribute clarification, things like that. Okay, that's all I have today. Thanks for listening, and please contact us for any questions you may have.